Class, welcome back. We have our next video of Chapter 5, and today we're introducing, or hopefully reintroducing, this concept of logarithms. Alright? Logarithms and exponential, they go hand in hand with each other. Okay? Exponent form, logarithmic form, very similar, very related to each other, and so we need to know how to go back and forth. So, to go from logarithmic form to exponent form, we're going to use what we call the log circle. Now, it's not a huge deal. You don't have to do this every time. In fact, I wouldn't want you to do this every time, but until you feel comfortable, I want you to understand that right now we would say log base A of x equals y. That's how we would say something like this. So what we are going to do is we are going to change this using our log circle to something like this. We're going to go A to the power of y equals x. Alright, so this part right here, a to the power of y, that's my first loop of my circle. Okay, that's 1 and 1. Equals x, this is 2. Alright, so what would we say here? I would say a to the power of y, a to the y, equals x. And this will always work. If you have a logarithm with base a and an argument x, so log base a of x equals y, it always switches to something like this. Alright? So, things that we need to notice here. Both log and exponent form, the base doesn't change. Alright? The base of my logarithm, the base of my exponential form doesn't change. Alright? Now, one thing we do need to check in on is domain. And I want us to think, when we're talking domain here, usually we figure, well, it could be positive, 0, negative. So if I take the log of some positive number, we're good. That's cool. What happens when I try to take the log of 0? Uh-oh. Can't do it. So we cannot take logs of 0. Can we take the log of a negative? Nope, can't do that either. Alright. So we now know that logs, this argument, has to be positive. Alright? Has to be positive. So now let's put all this together. Let's do some practicing. For these first few, I will continue to use the circle, just so you feel comfortable and confident with it. But really, if I have log base 3 of x equals y, I can always change it using my log circle. 3 to the power of y is equal to x. Alright, how about this next one? I might want to move this y over here, just so it's in the same pattern, or same form that we see, and now it's the same thing. Use your log circle. 5 to the y is equal to x. Alright, the next couple, same idea. We can still use our log circle. 3 to the 4th equals 81. We could check that, right? 3 to the 4th, yep, that's 81. And then lastly, I'm going to move my negative 1 over just to the right side so I can keep it kind of how I've seen it. And I'm going to say log base 5 of negative 1. Okay, so that's going to be my first part of my loop. And there's my second part. So 5 to the negative first equals 1/5, and we know that that is correct. Alright? Now, if we're going to rewrite in logarithmic form, there's a couple of ways to do this. So the first couple I'm going to let's see here. I'm going to start by writing log. I know it's going to be equal to something. We remember that the base doesn't change, so I'm still going to have a base of 1.2. But think about this now, guys. In all of these, what was happening? My solution, or my value that the whole log was equal to, became my exponent. Alright? So that is what we're going to have to kind of think about here. If my exponent is 3, then the 3 goes there, and the m would go right there. The other way to think about it, guys, is you can keep using your circle. It's just a little different. All right, something like that. So log base 1.2 of m equals 3. I can do the same thing on this one, right? Log base e of 9 equals b. And the last couple, if I use my circle, log base a of 24 equals 4. And lastly, that should be pointing at the x better. Sorry, guys. Log base 2 of 10 equals x. All right. So I need you guys to feel confident and be very capable of going back and forth between log form and exponential form. All right. This is important, because being able to go back and forth with them will allow us to help, or will allow us to graph better, and it will allow us to solve much easier. All right. So now on the next page, we get into some special logs. You might remember these. There are 2 special logs. One of them has base 10, and what we do is we just call that the common logarithm. And then there's another one where there's a base of e, and we call this the natural logarithm. And the reason that we call it natural logarithm is because this value, this number, it actually occurs in nature quite often. Now, the common logarithm, base 10, you're going to see something like this, guys. It's going to be like log x. And you might ask me, well, where's the base? Okay, that's the whole reason that they have this special log, because really, they're just saying that this is log base 10 of x. All right, this is what you're going to see a lot of the times. Sorry, I'm a little off the page. They're just not going to even put a base there, and you just have to know that if you don't see a base, what's the base? 10. Okay? Now this next one, and actually let me go a little bit backwards here. If we have a base of e, so something like this, log base e of x, a lot of the times, like if this is what you're thinking, we're not going to write it like that, guys. What we're going to do is we're going to write it ln of x. ln, natural logarithm. All right, I think it switched because of Latin or Greek, or I don't know what language this is coming from, but that is why the 2 letters switched. And I just need you to understand that if you see something like this, ln of x, that just means you have a logarithm with base of e. So for example, if we go back to our page before and we go down a little bit, hopefully you guys see right here, if I ever see something like this, I'm not going to write it like this anymore. Okay, I'm not going to write log base e. I'm going to say natural log. Okay, the natural log of 9 is equal to b. It's the same exact thing as saying log base e. All right, so let's jump into some practice with that. Rewrite next in exponential form. All right, so this is a little bit more the same. I'm not going to use my circle anymore because I'm getting really good at it, and I know that I'm going to say if I have log base a of 4 equals 5, I can write that as a to the power of 5 equals 4. Okay, on number 3 over here, be careful. We know that ln means that the base is e. If you need to, you can draw it in so you understand. But again, I'm hoping that you're feeling confident enough, even already, just understanding that ln means base of e. So it would be e to the negative 3rd equals b. All right, we keep moving. Let's see here. Oh, this is another nice one. 3 to the power of c is equal to 5. Again, use your log circle if you need to. And lastly, here's the common logarithm, right? I don't see a base, which means the base is 10. 10 to the second power equals x. All right? Okay, so now we get to use our calculator a little bit here. The log button is right here, right next to the 7. If you hit it, it doesn't allow you to plug in a base. It's only talking about the argument. So log of 7, excuse me, is equal to 0.845. And then we can do the same thing over here with ln of 9. ln is right below it. Natural log of 9 is equal to 2.197, or approximately, I should say, on both of those. All right, so please be really careful that you understand and you're seeing common logarithms and natural logarithms are really, really nice to put into your calculator. Super nice because we have the buttons. What we need to do is we need to talk about this concept down here in the box. When you do not have a common logarithm, okay, when you do not have a common logarithm, we have to use our change of base property, okay? And basically all it's going to say here is that you can take the log of the argument and divide it by the log of the base, and you get the exact same thing. All right, so log of argument over log of the base. What's really nice, guys, is sometimes it doesn't matter which type of log. Like here I used the common logarithm. I took the common log of both sides, or of both the argument and the base. I could have taken the natural log of the argument and the natural log of the base. Get you the same answer. You could even, though it won't work out very well, we already can't plug this into the calculator because it has a base, but just so you know, you could take like the log base 2 over log base 2. Okay, so the important property or important idea here is that you just use the same type of logarithm on top and bottom, top and bottom, top and bottom. So which ones could we use on the calculator? Common log and natural log. All right, this one would not be so helpful. This third one would not be so helpful for the calculator. So, again, I can't do this on the calculator as is, right? Because it has a base, it has an argument. I can't do it. What I need to use is the change of base. So, maybe let's do log 7 over log 2 and see what we get. Be really careful, guys. Make sure that you are punching everything in and closing brackets and whatnot. So log base 7, if you want, you can use the fraction. Where am I? Log 2, something like that. Hit enter, and I get 2.807. Again, just to prove my point from earlier, it doesn't matter which type of log you use. So if I used ln7 over ln2, let's see what we get. ln7, ln2, same exact thing. All right, so the important thing is that whichever way or whichever base you use the same on top and bottom. So if we move on to something like b, hopefully you agree this is just going to be log of 89 over log of 5, and you go to the calculator and you punch it in. Log 89 divided by log 5. Remember, you don't have to do fractions, it's just division. 2.789. And then our last one over here, log of root 5 over log of root 2. And let's see what we get. Log square root 5 divided by log square root 2. Okay, 2.322. 2.322. All right. So again, that is how you would use the calculator to figure out these three logarithms. You'd have to use the change of base property. We'll get into a little bit more about why that works, and you'll start to see it a little bit more in action as we move forward. Alright, last idea, last concept for this video, domain. Alright, we already figured out at the very beginning, we tested positives and negatives and zeros. You cannot take the log of 0 or negatives. So that means whatever you take the logarithm of must be greater than 0. So I call it the argument. Again, if I call this log base a of m, okay, m must be greater than 0. M must be greater than 0. It's the argument. It's what we're taking the log of. So when we take a look at letter A, and I see that my argument is x plus 3, I know that whatever's inside the logarithm must be greater than 0. So x plus 3 is greater than 0. X is greater than negative 3. Okay, this is really similar to the other domain problems we've done in the past. It's just now we have something new to add. We're not looking for a denominator. We're not looking for underneath a radical. We're looking inside of a logarithm. Okay? So, when I take a look at this, remember, whatever is inside of the log must be greater than 0, or whatever we're taking the log of, whatever the argument is. So here, inside my logarithm, or we're taking the natural log of x minus 7, so x minus 7 has to be greater than 0. And we're done again. Now C, I think C is kind of a goofy question. I don't know if I'll ever ask you this really, but it is important to understand conceptually what's going on here. What do we know here? We know that when we take the absolute value of anything, it will always be positive. Alright, so that means could I plug in a negative value here? I would say absolutely. Okay, absolutely. I know that I could plug in negative 5, and when I plug in negative 5 and I take the absolute value, it becomes positive 5. So what I want you to understand here is we can plug in anything except what? You have to remember what? We also cannot take the log of 0. Okay, so that's our only stipulation here, our only restriction, is that we cannot equal 0. We cannot plug in 0. Now letter D, we're getting a little more advanced now. It's the same concept, but look at my argument, or look what I'm taking the log of. It's a rational function. And I know that must be greater than 0. We just learned how to do this, guys. This is exactly what we just did with inequalities in our last chapter. We can't multiply by both sides. That'll mess up the signs. Let's see here. Oh, well, I can find some critical values, and I can plot on a number line. So I can see that I have a critical value of positive 1 in the denominator and negative 1 in the numerator. I know anything in the denominator will always be an open circle, right? Because we would not be able to graph that. There'd be an asymptote. And I also know because the sign is just greater than, I'm going to be open at negative 1 as well. Now you test. Okay, plug in negative 5. If I plug in negative 5, what do I get? I get a negative over a positive, which is negative, so I don't want that section. How about if I plug in 0? Ooh, a positive divided by a positive. This is good. That's what I want. And lastly, what if I plug in positive 5? Well, then I'll have a positive over a negative, which is negative. I don't want it. So now we just need to tell me the answer. You need to state your domain. So we would say the domain is either negative 1 is less than x is less than 1, or both of these options would be more than okay. Alright, last one, almost there. Inside our logarithm, we have this quadratic. I know that that quadratic must be greater than 0. Well, again, treat this either like last chapter, or you could go back to chapter 3, I believe, when we were doing quadratic inequalities. But I would factor. I would have some critical values. Let's see, 22, how about 11 and 2? Yeah, 11 and 2. And I would need a negative 9, so I'm going to have to go back 11, positive 2. Back 11, positive 2. Yep, there we go. So now I can plot my critical values. So I have 11, I have negative 2. Symbol is greater than, so I know I'm going to have open circles. It cannot equal 0. It has to be greater than 0. And now we test points. Let's try negative 5. Negative 5 would be a negative times a negative. So that's positive, and that's what we want. So I would shade there. Plug in 0. Negative and positive. So negative, positive, that's negative. I do not want that section. How about 15 for the right side? 15 would be a positive and a positive. So positive, and I do want that. So now I know where I would shade. The last thing I would have to do is state my domain. I would most likely go with interval notation here, just because it's a little easier. I would say I'm going from negative infinity to negative 2, union 11 to infinity. All right. If you wanted to use our kind of old method, we could say x is less than negative 2 or x is greater than 11. Both of these answers are more than okay. Alright, so basically guys, this video, I'm hoping that you understand how to convert or kind of change from exponential form to logarithmic form. And again, a lot of the reason that we're going to be doing that is because being able to go back and forth from one to the other will really help us when we're trying to solve. Alright, so that should do it for this video. I hope you have a great day. Peace.